In the world of software engineering, design patterns play a crucial role. They provide reusable solutions to commonly occurring problems. One such pattern is the Singleton pattern, a creational design pattern that ensures a class has only one instance. It also provides a global point of access to this instance. The Singleton pattern finds its application in various scenarios. It is useful when you need to control access to a shared resource, such as a database connection or a configuration file. It ensures that only one object interacts with the resource at a time, preventing conflicts and maintaining data consistency. Consider a scenario where multiple parts of your application need to access a configuration file. Without the Singleton pattern, each part might create its own instance of the configuration manager. This can lead to inconsistencies if different parts of the application have different configurations. By implementing the Singleton pattern, you can ensure that all parts of the application use the same configuration object. This promotes consistency and simplifies maintenance. The Singleton pattern provides a centralized point of control for accessing shared resources. The Singleton pattern is characterized by its simplicity and effectiveness. It restricts the instantiation of a class to a single object. This object is then accessible globally, ensuring all parts of the application use the same instance. The key concept behind the Singleton pattern is to make the constructor of the class private. This prevents other objects from creating new instances of the class. Instead, a static method, often named, is provided. This method allows controlled access to the single instance. When the method is called for the first time, it creates the Singleton object and stores it in a private static variable. Subsequent calls to return the same instance, ensuring only one object exists throughout the application's lifecycle. The Singleton pattern is particularly useful when dealing with resources that are expensive to create or manage. By ensuring only one instance exists, you can optimize resource utilization and improve application performance. Implementing the Singleton pattern in React.js is relatively straightforward. Let's consider an example where we want to create a single logger instance that can be used throughout our application. In this example, the class implements the Singleton pattern. The constructor checks if an instance already exists. If it does, it returns the existing instance. Otherwise, it creates a new instance and assigns it to the static variable. To use the logger in other components, you can simply import it and call its methods. This approach ensures that all components use the same logger instance, maintaining consistency in log management. In multi-threaded environments, ensuring thread safety in the Singleton pattern is crucial. If multiple threads attempt to access the method simultaneously, it could lead to the creation of multiple instances, violating the pattern's fundamental principle. To address this, you can use synchronization mechanisms like locks or mutexes. By acquiring a lock before accessing the critical section of the method, you can ensure that only one thread can execute the code at a time. In this modified code, a lock is acquired before checking for the instance and creating a new one. This ensures that only one thread can create the instance, even if multiple threads call concurrently. Once the instance is created, subsequent calls will bypass the lock, as the instance will already exist. The Singleton pattern finds practical applications in various domains. Let's explore a few real-world scenarios where it proves beneficial. First, database connection management. In web applications, managing database connections efficiently is crucial. Creating a new connection for every request can be resource-intensive. The Singleton pattern can be used to create a single database connection object that is shared across the application. Next, configuration settings. Applications often require loading configuration settings from files or external sources. Using a Singleton pattern, you can create a single configuration manager that loads the settings once and provides access to them throughout the application. Additionally, logging service. As demonstrated in the previous examples, the Singleton pattern is well suited for creating a centralized logging service. This service can be used to log messages, errors, and other relevant information from different parts of the application. Lastly, cache management. Caching frequently accessed data can significantly improve application performance. The Singleton pattern can be used to create a cache manager that stores data in memory and retrieves it efficiently. These are just a few examples of how the Singleton pattern can be applied in real-world scenarios. Its simplicity and effectiveness make it a valuable tool for developers looking to solve common design problems. The singleton pattern offers several advantages that make it a popular choice among developers. First, controlled access to a single instance. The primary advantage of the singleton pattern is its ability to ensure that only one instance of a class exists. This is crucial when dealing with shared resources or when you need to maintain a single point of control. Second, global access point. The singleton pattern provides a global access point to the single instance. This eliminates the need to pass the object around as a parameter, simplifying the code and reducing coupling. Third, improved resource management. By limiting the number of instances to one, the singleton pattern can help optimize resource utilization, especially when dealing with expensive objects. Fourth, flexibility and testability. Implementing the singleton pattern can make your code more flexible and testable. By providing a mechanism to override the creation of a singleton instance, you can easily replace it with a mock object during testing. Lastly, reduced global variables. While the singleton pattern does introduce a global access point, it can help reduce the number of global variables in your application. By encapsulating the instance within a class, you limit its scope and improve code organization. These advantages make the singleton pattern a valuable tool in software development. However, it's essential to be aware of its potential drawbacks and use it judiciously. Despite its advantages, the singleton pattern has some potential drawbacks that should be considered before implementation. First, it introduces a global state into the application. This can make it difficult to test and reason about the code, as the singleton instance can be modified from anywhere in the application. Secondly, the singleton pattern can lead to tight coupling between classes that depend on the singleton instance. This can make it difficult to modify or replace the singleton class without affecting other parts of the application. Thirdly, dependencies on the singleton instance may not be immediately obvious from the code. This can make it harder to understand the flow of execution and debug issues. Fourthly, testing code that relies on singletons can be challenging. Because the singleton instance is shared, it can be difficult to isolate and test individual components in isolation. Lastly, the singleton pattern is often overused, even when it's not the most appropriate solution. In some cases, it can lead to unnecessary complexity and make the code harder to maintain. It's crucial to carefully consider the potential drawbacks before implementing the singleton pattern. In some cases, alternative design patterns or dependency injection may be more suitable. When implementing the singleton pattern, it's essential to be aware of common pitfalls and follow best practices to avoid potential issues. First, ensure thread safety. In multi-threaded environments, proper synchronization mechanisms are crucial to prevent race conditions and ensure only one instance is created. Second, consider using lazy initialization to defer the creation of the singleton instance until it's first needed. This can improve performance, especially if the instance is expensive to create. Third, avoid global access from instance methods. Accessing the singleton instance from within its own instance methods can lead to tight coupling and make the code harder to test. Consider passing the instance as a parameter instead. Fourth, if possible, consider using dependency injection to provide the singleton instance to dependent classes. This can improve testability and reduce coupling. Lastly, clearly document the use of the singleton pattern in your code. Explain the rationale behind its use and any potential implications for other developers. By following these best practices, you can mitigate the potential drawbacks of the singleton pattern and ensure its effective implementation. The singleton pattern is a powerful tool, but it's not always the right solution. Here are some guidelines for when to use or avoid it. Use the singleton pattern when you need to control access to a shared resource. You need a single point of control for a specific functionality. The cost of creating the object is high and you need to reuse it. Or you need to ensure that only one instance of the class exists throughout the application's lifecycle. Avoid the singleton pattern when the object is not inherently shared or global. You need multiple instances of the class with different states. The class is tightly coupled to other parts of the application, or you need to test the class in isolation, and the singleton instance makes it difficult. Carefully consider the specific requirements of your application before implementing the singleton pattern. The singleton pattern is a valuable design pattern that can help you solve common software engineering problems. It provides a simple and elegant way to ensure that only one instance of a class exists providing controlled access to shared resources or centralized functionality. However, it's essential to be aware of its potential drawbacks, such as global state, tight coupling, and testing difficulties. The singleton pattern should be used judiciously and only when it's the most appropriate solution for the problem at hand. By understanding the principles, advantages, disadvantages, and best practices of the singleton pattern, you can make informed decisions about its implementation and leverage its benefits effectively in your software projects. Remember to carefully consider the context and explore alternative approaches before settling on the singleton pattern as your solution.